This video focuses on using circular motion formulas to calculate the maximum speed a car can go around the circle off of Rowan Boulevard in Glassboro, New Jersey. The formulas will also help us find the number of times a car can go around this circle in 1 minute. As you can see, my Bonneville is going around the circle at a slower speed. But through calculations, we will be able to find the maximum speed that any car can go before losing control while in the circle. To begin to calculate the maximum speed that a Pontiac Bonneville can go around this circle, you first need to know at least two things. One would be the radius, which happens to be 17.45 meters as off of Google Maps. And you also need to know the mass of the car, which of my 1994 Pontiac Bonneville, it came out to be 3,558 pounds, which converts into 1,613.88 kilograms. After you find that, you realize that the force of friction points towards the center of the circle. To go over here, you see that force gravity and force normal both cancel each other out, so that force friction would be the force net. First, you have to calculate the force gravity. To do that, you multiply 9.8 meters per second times the mass of the object, which was 1,613.88 kilograms. It came out to be 15,816.024 newtons. Because the force gravity and force normal go in opposite directions, they are equal to each other. Next, you take the force normal and you plug it into the force friction formula, which is force friction equals the coefficient of friction times force normal. The coefficient of friction is 0.65, which is the medium between 0.5 and 0.8, the coefficient of dry asphalt against a tire. That came out to be 10,280.416 newtons. Next, you plug the force friction to be the force net into this equation. Force net equals mass velocity squared over radius. After you plug all of those in, you get the final velocity, maximum velocity, to be 10.54 meters per second, which converts into 23.58 miles per hour. That is your maximum speed you can go around that circle. Next, I wanted to find how many revolutions per minute you could go around the circle. You use this equation, velocity equals number of revolutions times 2 pi r over time. You want to use the velocity we found in the last equation, 10.54 meters per second, and plug in the rest as we used before. You want to use 60 seconds because we are using revolutions per minute. 60 seconds is in 1 minute. After you plug all of the numbers in, you find that you can go around this circle 5.77 times in 1 minute.